just so everybody knows that my name is Heath Madison. I'm our Senior Director of Consulting Services at US Cloud. So we're very excited to have our partner Sketch Development come join us today for this advisory hour, on which we'll be talking about using OpenAI APIs to build AI assistants for your own applications. We're really excited about that. For those of you that have not attended one of our advisory hours before, but I know you're not here to listen to me talk. You're here to listen to David talk about the topic at hand. So I am going to hand it off to David, once again, from our partner, Sketch Development, to talk about this. Thanks, David. Take it away.
All right, thanks, Heath, and thanks everyone for joining today. And like Heath said, today we'll be talking about building AI assistants using the OpenAI Assistants API. Before we get started, just a little bit about myself. I'm a developer and architect at Sketch Development Solutions. I've been a software developer for over 20 years and have been using the OpenAI APIs for about the last year and a half. And I'm excited to show you guys how easy it is to use their APIs to add artificial intelligence to your applications. So let's start at the beginning. What is an AI assistant? An AI assistant is just simply a software application that leverages artificial intelligence to assist users in performing tasks, answering questions, managing information, or providing insights. And any good AI assistant should have the following feature set. First, needs to be able to understand and respond to human language. Second is information retrieval. So it should be able to search across different data sources. It could be web, it could be documents that you upload, and then pull data from those sources to answer users' questions. Should have some learning capabilities. So over time, the assistant should be able to learn from its interactions, become more personalized and more efficient. It should have some tool integration. So if you want your assistant to do more than just respond with text, you need to integrate it with different APIs. These could be SaaS applications or your company APIs. So the AI could perform tasks for you or maybe get some real-time data feeds that it leverages. And then finally, some dynamic problem-solving capabilities. So if you ask a pretty complicated question of the AI, it should be able to create an execution plan and then execute on the tasks in that plan to come up with a solution. Here's just a few use cases for AI assistants. First one is pretty obvious. You could build a chatbot as a customer support bot that you put on your website to handle customer inquiries and questions with 24/7 support. Content generation, you'll see these already also in AI to help with writing articles, blog posts, social media updates, and even marketing copy. You can use it for educational tools. So Khan Academy has released an AI that helps teachers create their curriculum, and it also acts as like a personalized teaching aid for the students to help them understand things. Financial analysis, you could build an AI that consumes a ton of financial data, like annual reports or news articles, press releases, or even metrics about the stock price, and then uses that data to provide insights or recommendations. Contract review, an AI might analyze legal documents and flag potential issues for someone to follow up with. E-commerce, you could provide customized recommendations for your clients, assist with order tracking. You could even use it to manage your virtual storefront. And finally, supply chain management. You could have an AI that's monitoring your inventory levels, using different data feeds to predict demand, and then maybe even automating the reordering process for you. So these are just kind of a handful of use cases. I encourage you as we go through and learn about the features of OpenAI to think of how you can use those within your own organization. So yeah, lots of different LLMs and ways to build on top of AI now. So Facebook, Google, Anthropic all have LLMs and some APIs you can build on top of. We'll be focusing on OpenAI, specifically their Assistants API. If you're unfamiliar, OpenAI is the company behind ChatGPT. They're really the first and most successful to leverage these large language models to create some generative AI. They have a newer API out now called the Assistants API that allows you to build these purpose-built AI assistants and has all the endpoints you need to integrate it within your application. And I also wanted to point out that today I'll be walking through like OpenAI's documentation and their APIs. But if you are using Microsoft Azure Cloud, they do offer an OpenAI assistance preview in the cloud as well. It's a one-to-one correlation of what we're going to show today, but they have some added privacy and security and content filtering to make it maybe a little bit more enterprise ready. So this diagram here shows kind of what an AI assistant looks like within OpenAI. The central concept is an assistant. You start by creating an assistant, and then you associate different features or tools with the assistant. At the top, you'll see the LLM. So the first thing you do after you create an assistant is associate it with a model or a large language model. You can pick from a number of different OpenAI large language models. Today, we'll be using GPT-4o, which is the most recent or the most capable one available to the API. If you've been following the news, you may have read that just last week, they released a new one called O1, which is even more powerful. It's not quite available to the APIs yet, but I expect that to be available soon. One note on the LLM is some of them are larger and more capable, but they're also kind of more expensive and can be a little bit slower to respond. They have other models like GPT-4o Mini, which are smaller models and they're faster and cheaper, but they're maybe not as accurate. So depending on your use case, you might pick a different model. Usually you start by optimizing for accuracy and then optimizing for cost and latency speed. After the model, you have 3 tools available to your assistant. The first is file search. File search allows you to augment the large language model with data that's specific to your assistant. So you do this by uploading files through an API to the assistant. When you upload them, OpenAI will create embeddings and put those into a vector store. The vector store makes it really easy for the assistant to query for the data it needs. The second tool is function calling. This allows you to define functions that the assistant can call. This is just defined using a simple JSON and plain text describing what the function does. You also need to tell what parameters the function expects, and then the assistant, based on the message that it receives, can intelligently decide whether or not it needs to call a function to answer that question. Third is code interpreter. This one allows the assistant to actually write its own Python code and run it in a sandbox environment within OpenAI. So this is useful if you have like a large structured data set that you need the assistant to either summarize or convert it into a chart or a graph, or if you have some sort of difficult mathematical problem you need it to write code for, it can use the code interpreter for that. And the last thing on this chart is not really a tool, it's more of a feature. It's a concept of persistent threads. So you can start a conversation with the assistant and carry on that conversation over time on a single thread. So the assistant knows like what you've talked about in the past and has that memory to pull from. So I wanted to dive a little bit deeper into the tools because these are like the meat and potatoes of the assistance API. Like I said, file search allows you to augment, it allows your assistant to become an expert on whatever use case you have. You can upload up to 10,000 files, and each file can be up to 512 megabytes. Second is function calling. So that there you define the function in JSON, that all of the functions, you can define multiple that are available to the assistant. The assistant doesn't actually call the function directly, but instead, when you invoke the assistant, if it determines it needs to call a function, it responds back to you saying, hey, I need you to call this function for me. Here's all the parameters I want you to call it with. Then you call the function, get the outputs from that function call, and return it to the assistant. And then the third was like code interpreter, which I think we talked about. It just allows the assistant to write its own Python code. It is interesting. It will write its code, and if it's not accurate, it will try again. So it has like a loop where it can run the code multiple times to get it right. One thing I wanted to point out, these 3 things are like powerful independently, but they can be called together. So on one call to the assistant, it may do all three of these things. It may call file search, invoke a function to return some real-time data, and then maybe take that real-time data and write some code to parse it and summarize it. One more slide before we like dive into kind of the hands-on creating or using these APIs. I just wanted to go through some of the terminology in the Assistants API, specifically the objects that they define in their API. First and foremost is the assistant. The assistant is your purpose-built AI. It uses the OpenAI models like GPT-4o, and it can call your tools, which are the file search, the code interpreter, and the function calling. The next concept is the concept of a thread. So whenever you start a new conversation with the assistant, you have to start a new thread. So the thread is a conversation between an assistant and a user. The thread will store messages and it automatically handles truncation to fit within the model's context. What that means is each model, like GPT-4o or GPT-4 Mini, has a limit on how many words can fit within a single conversation. This will automatically truncate off the older content for you. This is kind of nice in older APIs, like the chat completions API. This is something you had to handle manually, so it's nice that the Assistants API handles that for you. Next concept is a message. So the message can either be created by the assistant or by the user. It can include text, images, or other files, and it's stored in a list chronologically on your thread. And then the last kind of important concept is this concept of a run. So after you've created your assistant and you've configured it with the model and the tools that it has available, and you've created a thread and added a message to it, nothing happens until you create a run. And a run is like an invocation of an assistant on that thread with the message on it. So the assistant uses its configuration, then it uses all the messages in the thread to figure out what task it needs to perform. Those tasks could be calling models or tools. And then once it's done performing those tasks, it comes up with its message as a response and adds that back to the thread. This last concept here, we won't really cover much, but it's good to know it's there. This is run steps. So whenever you start a run, the run consists of a number of steps. The assistant kind of takes care of that, but you can look at those steps if you're curious to see how the AI got to the result that it did. All right, so let's dive into actually creating an assistant. If you're new to OpenAI, the first thing you'll need to do is go to openai.com, create an account and sign in. And then we'll create an API key that we can use with the APIs. So I'm going to go ahead and show you that. If I go to OpenAI, you go to products, then API login. I'm already logged in, but if you're not, you would see your typical sign-in screen with a button that says create account. If you're new, you can create an account and log in. Once you log in, you'll see this. I'm going to go to the API screens here. And from here, I'm going to go to my dashboard at the top, and on the left, API keys. So I can create a new secret key by clicking this button. When you create a key, it can be owned by you personally, or it can be owned by a service account. This is like my personal OpenAI account, so I'm going to own it by myself. But if it was for a company, you'd obviously want to create a service account so it wasn't owned by an individual. You give it a name. You can organize your keys into different projects. There's also these permissions. You can make it a read-only key or restrict it to certain endpoints, but I'm going to give it all permissions. And then you hit create secret key. Now I have the key. This is the only time you'll ever be able to view the key, so make sure you copy it here. And I'm going to real quick paste that into a environment variable that I have in my code, and we'll come back to that in a minute. So I've created a key. I've put it in a environment variable in our code. One other thing I wanted to show you on this dashboard before we start writing code and calling APIs, there is this assistance tab on the dashboard where you can, just through the UI and through a playground, create an assistant and test it out. So I'm going to create one here. I'm going to call this webinar test. I'm going to provide it some instructions. The instructions are important. They tell the assistant what it is and how it should behave. I'm going to copy a prompt I have already set up here. It just says, you are a financial analyst. You'll provide insights and recommendations regarding a company's financial outlook. Typically, I like to start kind of broad like this. And as I test the model out or the assistant out, I'll tweak the instructions to get it to behave just how I want it to. So if it's returning responses that are maybe too long, I'll ask it to be more concise with its responses. If its responses are really basic, I'll tell it to write at an expert level when it responds. You can have it take on a persona or speak with a certain tone. You can have it respond in a certain format, and you can even provide examples of how that format should look. So just wanted to point out this is kind of an important piece here to get the assistant to behave just how you want it. The next thing you pick is the model. Like I said, we'll pick 4.0. You can also pick 4 mini or some of the older models they have available. We're going to enable file search. This is what allows us to upload additional data that the assistant can use. And I'm going to upload a file here since this is a financial analyst. I'm going to upload Apple's most recent annual report. This is the 10K to submit to the SEC. It's like a 80-page, pretty dense document full of financial information about Apple. When I update it, you can see it's creating a vector store and adding the document to it. And then you can enable code interpreter. You can enable functions. There's a couple other options. Temperature and the top P. These are different ways to affect how random or deterministic the responses are. So a higher temperature would result in kind of more random responses that maybe are more prone to hallucinate, but they're also way more creative. Same with the top P. So if you want something really creative, you go with a high temperature. If you want something like consistent and deterministic, you'd go with a lower temperature. So I'm going to leave these as the defaults. I'm going to go to the playground and we'll just test it out right here. So I can ask, who is on the board at Apple? I'll hit run. So it is finding the board members. But it even gives me a little annotation telling me it pulled this data from this document that we uploaded. So with no code, this is like a pretty easy way to test and build an assistant, prove out maybe a use case. It's pretty powerful. You can kind of show it off to your boss and see what they think about your idea. So let's see how to do this in code. We've created the assistant. I showed you how to use it in the playground. We're just going to go through some live coding now where we actually create an assistant using code and the APIs. We're going to update a little chatbot to use this new AI assistant that we have. Then I'll show you how to implement function calling, and then I'll show you an example of using streaming, and we'll talk about that in a minute. Before I do that, I just wanted to open up a couple links here. These are the documentation for using the OpenAI APIs, and I'll kind of go back and forth between these just to show you how easy it is to use this documentation to build your own assistant. The first is just a generic how to use the API. The second link here shows specific API calls, fields that are required, and then what the responses look like. So first, in the assistant's quick start, you can see they have an example of how to create an assistant. That's the first thing we're going to do is we're going to use the OpenAI SDK to create an assistant. Now, OpenAI has an official SDK for Node and Python. They have an SDK for .NET that's in beta. And then there's a number of open source implementations for different languages. Let me go to our code here. This is a Node application built on SvelteKit. SvelteKit is just a framework for building full stack Node applications. I'm going to go ahead and start the app and just show you what it does. We built this as like a little test app for this webinar. This is Finley. It's a financial research companion. The way it works is a financial analyst can come in here, search for a stock, hit research, and then get some information about the stock. This is calling some APIs to get analyst ratings, current stock price, earnings estimates, and then you can see here's the latest annual report from Apple. There's also a little chatbot that you can ask questions to, like, let's see, what is the current stock price and what is the average earnings estimate? Is maybe stock price, the earnings estimate. But if I ask who is on the board, it says, I don't know that. What do you think I am, an AI? So it's a very simple one, no AI integrated. So what we're going to do is two things. First, we're going to create our assistant using code, and then we're going to add that assistant to this chatbot. Let's go back to the code. I've created a route already to save us some time to create the assistant. So under admin, create assistant, there's a simple web form. Actually, before I do that, we need to install our OpenAI SDK. So from a command prompt, I'm just going to do an npm install OpenAI. It's downloading our OpenAI. Looks like there's some vulnerabilities, so let me just fix those. And you can see in my package.json, there's a new OpenAI package that was added. So in the code, there is a route or admin create assistant. It's a simple HTML form that has 3 fields: an input for the assistant name, an input for the instructions, an input for file uploads, and then just the create assistant button. And then when this submits, it goes to a backend service here that gets the request data from the form, and it's pulling out the name as a string, the instructions as a string, and a list of files. So what we need to do is actually create the assistant using the OpenAI SDK. So to save us some time, I put some code in here. I'm just going to uncomment it and we'll talk through it as we go. So first thing we're going to do is import OpenAI from the library and then create an instance of our OpenAI class just by saying new OpenAI and passing it that API key that we're going to create from, the API key that we created already from our environment variable of OpenAI API key. So once we have an instance of this OpenAI class, we can call the function to create an assistant. So that's as simple as this: OpenAI.beta.assistants.create, and it accepts a name. We're going to use the name from the form, some instructions, the instructions from the form, what tools are enabled. Right now, we're just going to enable file search, and then the model. So this call will call an API, create the assistant, return the assistant, and it'll have an ID on it. Next thing we're going to do is log that ID to the console. And that takes care of creating the assistant, but it doesn't actually upload any files to the assistant. That's where this next block comes in. Here, I'm just checking to make sure there were uploads from the form. If there are, then I'm going to call the OpenAI beta vector store create. To create a new vector store, I just provided a name, and that returns a vector store object. After I've created the vector store, I need to upload these files that we've pulled down from that form submission to that vector store. So that's as simple as using the SDK saying OpenAI.beta.vectorstores.file-batches.upload and pull. This is a helper method that does a few things. One, it uploads the files to API and OpenAI, and then it adds them to the vector store. And because these are asynchronous, it's going to pull and wait for those to be done before it returns. This function takes 2 parameters. One is the vector store ID for the vector store we just created, and then the files. So these are the uploads from the web form. Finally, so we've created our assistant, we've created our vector store, we've added our files to the vector store. Next step is to update our assistant to associate its file search with this vector store ID. So we're just calling the assistants.update, passing in our assistants ID. And then in the body, we're saying for the tool resources file search, the vector store IDs that we have for this file search are the vector store we just created. And then when we're done, we're just going to redirect to a page that shows some details about this assistant that we just created. So this is just a redirect to the admin.assistants.id. This is just a simple page showing the ID for the assistant we just created. So that's it for creating a system. Let's test it out and see if it works. So I'm going to go to the route we created, admin/create assistant. Here's a form, and we can give it a name. We're going to call this Finley webinar. We'll provide it some custom instructions. You are a financial analyst. And remember, you can get really detailed in these instructions. We're going to choose a file. We're going to upload that same Apple annual report and then hit create assistant. This is making a call to the back end, which is calling our APIs to create the assistant, upload the document, and then attach that vector store back to our assistant. All goes well, it should forward to a page with that assistant ID. There it is. So you've created an assistant with this ID. I'm going to show you real quick. If I go back to the playground and refresh this page, you can see now that we do have our assistant we just created with our API key. It's available in the playground. These are the instructions we gave. That's the vector store we created with the document. So you can test it in here as well. So we've created the assistant. I'm going to copy this ID, but if you recall, our chatbot is still not enabled with AI, still doesn't know the answer to that. So that's the next thing we're gonna do is we're gonna update this chatbot to use this new assistant that we created. The way this chatbot works is this is just a form. When I enter data in here and hit send, it's gonna make an API call to the back end with some JSON that sends the thread ID and the message that I typed in here. That service then comes up the response, returns it to the front end, and it's displayed in this area here. So I'm going to go to our API that the chatbot calls. So under API, I go assistant ticker. There is a service on the back end. The rest of this, if we look at what it's doing today, it's just taking a post from a form. It's getting the JSON from that post and storing it into a user message object. This user message is of type thread message. It just has a thread ID and a content variable. It checks to see if the thread ID is null. That means this is a brand new thread. Right now, it's just creating a random new thread ID. And it's pretty basic now. It's just looking for the content of that message to see if it includes some strings like hello or hi or stock price. If it includes stock price, it's calling our API to get the stock price and returning that back to the front end. If it doesn't match any of these, it just returns I don't know how to do that. So pretty basic, not at all what we want. So I'm just going to delete this code and we're going to replace it with code that includes our AI assistant. So to do that, first thing we need to do is, again, create an instance of our OpenAI client. Someone commenting some code here. We're importing OpenAI. We're creating a new instance of this OpenAI class and passing it our API key. And then here, if the thread ID is null, first thing we need to do is create a new thread. I'm going to go back just to this quick start documentation. Kind of walks you through this. So the first time you do it, you'll be able to go to the assistant's quick start and kind of follow through this documentation. First thing it talks about is creating a thread. So I'm going to copy that. And from here, if the thread is null, I'm going to create a new thread calling OpenAI beta threads.create. I'm going to do something a little bit different though, because our endpoint is for a specific ticker symbol. I'm going to give the AI some context when I create the thread so it knows that questions that it's getting asked are about this ticker symbol. So to do that, I'm going to pass in some messages, and the message is going to have a role, user, and some content. And the content is just going to say, if not specified, all questions in this thread are about the ticker symbol ticker. The ticker I'm pulling from the URL here. So the request is API/assistant/Apple. That's just where I'm getting that from. And I'm just telling it when I create the thread, hey, unless I ask something else, assume that all questions are about the ticker symbol for this API call. Now, after I've created that thread, I'm going to, instead of setting this user message thread ID to a random one, I'm just going to set it to the ID from the thread we just created. Next thing we need to do is add a message to that thread. So going back to the example here, here's an example of how to create a message on the thread. I copy that. And this is going to call the OpenAI beta threads messages.create. It expects a thread ID. So I'm going to use the thread ID I put on the user message. Again, I'm adding a message. It's going to have the role of user. And then the content is going to be the user message.content. This is the value that was typed in to the chatbot on the front end. So we've created our thread. We've created a message, but nothing happens until we invoke a run. Here's how to create a run. There's on the On the documentation page, it shows with streaming and without. I'll show an example of with streaming later, but it's just easier to understand without. With streaming, what happens is OpenAI opens up a server-side event. You listen to those events and react to them. It could be new words added to the message or a request to call a function. But without streaming, like we're doing here, it just comes up with a complete response. We take that response and return it to the front end. So here we're creating a run, and we're using the OpenAI beta threads runs.create and poll. We're going to give it our thread ID. We're going to give it our assistant ID. So the assistant ID is the one we just created through the form. Usually you'll put this in a database maybe or in an environment variable. I'm just going to put it in a variable up here. And I need to grab that. I'm going to grab it from our playground here. Here's the assistant ID we created. It's going to hard code it here. So we're going to pass in create a run for this assistant ID. We don't need to pass any specific instructions here. When the run is complete, we check the status of it, and then we get the latest message from the thread. So that looks like this. We check the status of the run. We get the messages from the thread, and we're going to get the latest one and return the text of that. This is the last step before we can return a response to the front end. So after we've created the run and we're polling for a response, if the status is completed, I'm going to get all of the messages from that run, and then I'm going to, this example here is like looping through them and just printing them off. What I want to do is get the last message from the messages. It's always reverse chronological order, so the newest message is always the first in this array. So I'm going to grab that, and then I'm going to get the text from this message and use the same convention they used here. I'll show you how what this means in a second here. But this message is an object. From this object, I'm going to get the content. And then from the content, I'm going to get the text object and then the value of that. And I'll show you what that looks like in a second. And finally, I'm going to return some JSON, and then this is going to have a thread ID with our thread and then the message text. If the status is not complete, for our example here, it means we had an error because we're not doing anything with function calling or code using the code interpreter. We're just returning text. So usually you would check the status and do different things, but for now, I'm just going to return a generic, I'm sorry, but something went wrong. Please try again. And I'm going to delete this. All right. So we've created a thread. We add a message to that thread. We invoke a run for this assistant and that thread. When it's complete, we're getting all the messages from the thread. The first one is the message that came back from our assistant. We're getting the text value from that and returning it to the front end. And just before I demo that, this message content text value, if you go to the API reference and look at the messages list API, which is what we're calling, you can see it returns data as an array. Each one of these is a message. Each message has a content. We want the one of type text, and we're getting the text value. My code is taking some shortcuts because we know it's only returning text. We're not doing anything with images yet. But if you were, you'd have to check the type there as well. So this should work. Let's test it out. I go back to our assistant. We say hello, taking a little bit longer. So that's a good sign. It means it's actually calling our AI. Hi, how can I assist you today? Let's ask it who is on the board. Now you'll notice a little bit slower because I'm not using streaming. If you're using streaming, it'll start returning the text and displaying it as soon as it comes back. But you can see it did find the board of directors from this document. You can even ask it some more complicated questions like what are the biggest, let's say, 3 biggest risks facing the business. And if it's more complicated like this, it'll generally take a little bit longer to come up with a response because it's scanning the whole document and coming up with a reasonable response or what the biggest risks are. You can see it gave the top 3 in its opinion with some reasoning why these are risks. Just wanted to show one other thing. There is like a ton of data and tables and tabular data in this document. So let me find some, maybe, here we go. There's a table. It's asking for net sales by reportable segment. So let's say you had a ton of documentation, but you're curious in finding the net sales by reportable segment. You could come here and just ask, what is the net sales by reportable segment? So I wanted to point out that in this table, there's a note at the top that says these figures show dollars in millions, and then it has a table with the dollars here. I just want to point that out because it did return the response or the data from this table, and it knew that this was not 162,560, but instead that this was in millions, and it represented that correctly. So it was able to find context outside of this table and tie that together. So that was pretty easy. We quickly created an AI assistant, and we've hooked it into the APIs to make requests and get data back. You can see it working here. I just want to real quick show a couple other things without diving into the code too much. Let me just commit these. I'm going to pull down a branch that has function calling just to show how you implement that. Function calling allows your AI to do tasks beyond just returning text. When you enable function calling, you're kind of doing two things. First, when you create the assistant, instead of just adding file search as a tool, you're adding the functions that are available to this AI in that definition. You can see this says you have a tool called function. Here's the name of the function, gets stock price last 30 days. It gets the stock price for the last 30 days. You can put a description of exactly what that function does so it knows when it should call it. You define the parameters. In this case, it accepts an object with a property called ticker, which is of type string. And this is the ticker symbol of the stock. And then you say which fields are required. That's all you have to do when you create the assistant. And then when you invoke a run, you'll have to make a change there to look for the AI to request a function call. So this is our code for our endpoint for our chatbot. All of this is the same, but at the bottom here, after we create the run, instead of just looking for complete and returning the text, we're handling the status a little bit differently. We have a function that checks to see if the status is complete. If it is, we're just doing the exact same thing we did before. If it requires action, that means we need to call a function and return that data back to the AI. So we have this handle requires function, handle requires action function that checks to make sure it wants us to handle a submit tools output, and it's given us a list of tools or function it wants us to call. And then we have to loop through each one of these tool calls and create an output that we pass back to the AI. So to do that, we're looping through and mapping those to these tool outputs. And we're just looking for the function name that they asked us to call. If they asked us to call get stock price last 30 days, then we're going to call our get stock price last 30 days and pass it the parameters that it told us to pass to that function. And then when we get the data back, we're going to return back to the AI an object that has the tool call ID for the tool call they requested and the output of our function call. And then we're going to submit all those outputs through an API function here called submit tool outputs and poll, where we say for this run or for this thread ID and this run ID, here's the outputs you requested from us. We're sending them back to you. After we send them back to you, then we handle the status again. Hopefully it's complete this time. And we just take the message and send it to the front end. Let's just see how that would work. Can you tell me the latest stock price? So since we've enabled that function, now the AI can know it needs to call our get stock price function, ask us to call it, we'll return it to the front end, and it'll use that data. So it says, yep, the latest stock price was $217.88. Looking at our logs for the application, we can see, yeah, we did log out that we successfully submitted those outputs back to the AI. So that's function calling. I only have a few more minutes. I just wanted to show streaming, what that looks like. I'm going to check out the streaming branch. Streaming essentially uses server sent events. So instead of making a request to the backend and just waiting for a response, we make a request and then we listen for events coming back from the OpenAI API. And when streaming happens, we'll get a response faster and we can show the data as we receive it. So we're just opening up a connection, listening for those server sent events. And then when the connection closes, we can close our call to OpenAI. And that code is a little bit more complicated, but you can see in the quick start guide, if you look at the with streaming section, it has an example of how to do that as well. Right. So there was a ton of information. We kind of flew through creating an AI, adding it to a chatbot, showing how to implement function calling, and also what the streaming API looks like. There's way more I wanted to show, not enough time in an hour, but just wanted to talk about some of the other features that are in OpenAI that we didn't touch on. One is like image inputs. The newer models accept images. You can upload images to your assistants and ask questions about the image. It can describe it. You can upload two images and ask it to find the differences between them. It can generate images for you using the DALL-E 3 API. There's a really good speech to text and text to speech APIs if you want to create like voiceover for your text. In Azure, there's some video transcription APIs. I've used this for translation before. It's pretty good at translating from one language to another. And batch completions is another new API that they offer. If you have a bunch of tasks you want the AI to complete that don't need real-time responses, so maybe you're trying to translate a bunch of documents from one language to another, you could batch those up, call their batch completions API. You won't get immediate response, but it'll complete within 24 hours, and it's 50% cheaper than using the real-time API. One other thing here, this is interesting. This is a quote from Paul Graham, who is the founder of Y Combinator, which is the largest startup incubator in the world, probably. He recently tweeted out saying multiple speakers at startup school made the very same, very interesting point. If you start a startup now and do something that barely works with AI, the next models will make it really work. I mean, this doesn't really just apply to startups. It applies to anyone who's building on top of these AI models. Like I've seen it when OpenAI went from 3.5 to 4.0. There was a huge leap in accuracy and functionality. So if you start building now and something sort of works or isn't exactly perfect, it'll keep getting better as these new models come out. And before we jump into the questions, just wanted to briefly go through some services that we offer at Sketch. If you are thinking about doing something with AI, we have a service that's an AI consultation. This is like a 2-hour phone call with some of our developers and product owners to help you brainstorm different use cases and solutions and maybe help you identify next steps. Beyond the consultation, we also do an AI design sprint. This is like a full 1 week with Sketch where we do an assessment of all your current technical capabilities, explore multiple use cases, help you identify which is the most high value use case, and then work with you to generate a roadmap and even a backlog of work that's required to create a proof of concept or MVP. And beyond that, if you are interested in developing and would like some help, we have a number of developers here who can work with your team in an iterative approach where every 2 weeks we plan and design and deliver some sort of working software that we demo. We love doing this type of stuff. And if you're interested, we'll be sending out this presentation with some contact information after the webinar. All right. So are there any questions? Let me go here to the questions here. I see a few in here. So first one, I noticed these functions are in beta. Okay, that is true. The OpenAI Assistance API is currently in beta. It's been out for quite a few months now, but yeah, you should know that it is still in beta. Is this session recorded? It is recorded, and I think we'll work with Heath to make sure that gets sent out to everybody. How do you format the data that comes back from the assistant? That's a good question. So you'll notice that when the data was coming back, it had bullet points and headers. OpenAI does return all of its responses as Markdown. I was just using a library called Marked to convert that Markdown into HTML. And thanks again, everyone, for joining today.
Thanks so much, David, for that in-depth explanation and kind of demonstration of the capabilities. Very exciting stuff. Thank you so much.
All right, you're welcome. Thanks for having me.
Have a great day, everybody.